So let's go through some more nested and complicated usage of dictionaries. Suppose you got a dictionary of this kind. First you got your name, and after name, in name section also you got two fields. Suppose for example take first name. First name is your what? Then in your second name, sorry, last name, is your caste. Okay. After that you get a field like what's your age. Suppose your age 22. Another field is like your what job. Here you got a dictionary, and in dictionary you got two fields. First your job is what you say, field manager. So basically you're doing this guy is doing two kinds of job. One is managerial and one is on field. Sorry. So what's your dictionary? Okay. Oh yeah, okay, fine. Nothing, just dictionary got sorted and job came over here. So now how do you access and just filter out all of these things one by one? Basically accessing this field is quite simple, but how do you access? Okay, first let's get all of these key values like job, age and your name. Okay. Okay, let's first find out the keys. What all are the keys? The keys are name, job and age, all these. Now you know how to get the values of these. Just simply do, basically just pay attention. All the d1 dot keys returns your list of all of the keys. Now you can access the values one by one. So now you can simply run a for loop for x in d1 dot keys. Print x of the value. No, sorry. Now okay, let's first print x. So now your list is the list of your where it is, list of all the keys printed here. Now you can just how do I explain it, like d1 dot keys, the first field, first element, which is numbered 0, will give you the first name, job, first element of this list. Now how can you access the job here? How can you access the value field of this key? So this gives you the key. Now you circle it in parentheses and then you give again d1, sorry, list name. So it will provide you the value. Where's this bloody job? Here, the value of the key job, correct? So this is basically, this can be useful when you are doing it. You got a very long dictionary, maybe 100 or 120 or 150 fields in it, so you cannot do this every time. Do this 0, then how would you access? If you make it 1, it will give you 20, because now keys dot 1, the first element, sorry, the second element of your list is age. Now if you find out what are the values of the key age, it will provide you 20. Now again, now this provides the names. So the third element in the list, where is it? In this list, the third element is name. So you get the values of corresponding to all of the keys one by one. Job, yeah, jobs values, age values, and the value of key named name. Correct. Now you can again run it through a loop. Now I'll tell you one thing more. What is the length of this dictionary? 3. So basically, what is the field which is changing here for accessing all of the individual values of the keys, corresponding keys? So this is the field changing 0, 1 and 2. So you can run a loop for I in length of d1. Oh, sorry. No, again made a mistake here. Let's take the braces. Yeah. So if you create a range which holds the last limit up to the length of this dictionary, so you can iterate through all of the element numbers and you won't run out of the loop also, so that index doesn't go out of range. So now you can use these fields as a triple item. Use this one as replace this digit with I. Let's do this for I in range length of dictionary. Print. Okay, so now every time the loop iterates, this I gets changed. First it becomes 0. It will give you the key value, the value of the key which is at location number 0, and then one by one that becomes 1, then it becomes 2 and finishes the loop at 2. Okay, so the values of the field of the key job, the value of the key age, and the value of the key name. Now another more interesting thing that these both values are again having a list and dictionary in themselves. So how do you actually now access the elements of field and manager, both of these jobs types? So if you remember, how did we get this field? Okay, so now to access each and every element of this, let's first find out the length. Length is 2. Now you can print out. See, because this is in practical situations you won't find values and the list very so small. There will be hundreds and thousands of names, or a person can have portfolio which is not limited to 1 or 2 jobs. A person can be a manager, some other post holding in field, some other thing when he's in the marketing field, or maybe 3 or 4 portfolios somebody can hold. So you can go through a loop, create a loop up to the length, up to the limit which is having a length equal to the value, equal to the number of keys and values in the dictionary. And what becomes, sorry, not dictionary, list. Now what is the list now? The list is this one. Now you got to get this. d1 dot keys of I. No, sorry, it's a mistake here. Okay, how did you get these two fields, field and manager? This was, now I here is something which will confuse you. Basically I denotes to the value, corresponding value of each and every element of the values corresponding to the keys. So you cannot use this I here, because this I takes out the individual elements of the list. So I guess I'll have to create another field here. So d1 dot keys value give you the list of all the key names, where it is job, no, age, job, age and name. Now we need to access job, and job is at the location number 0. So let's use just wait, d1 dot keys provides you a list and the first element, correct? Now this is the first element, that means job. It will give you just job. And what are the values? I got to again and close it in parentheses. Now this is going to provide you these both fields. Now how do you access field? So basically very simple, the first element of the list is accessed by using 0. Okay, now with this you are going to access only the first element. Now we are using the loop here. The iterator is I, so I will change from 0 to the length of the keys. So basically just replace it 0 with I. Okay, let's hope it runs. No, made a mistake, something. Unhashable type list, so it is basically returning us a full list. Let's troubleshoot through it. Okay, no, let's make it from starting. Basically these things are so much nested that sometimes you get screwed up sorting them. Okay, now here we got your job. Actually I made it too much complicated. Job, age, name, first field job, the value is field and manager. Now how do we access this? 0th element gives you field, and first element of the list, this list, will give you the second post he is holding, manager. Now it becomes pretty straight that the changing field is over here is this one. So quite simple. For I in, you create a list by using this range function. We had seen it in the previous topic. Range of d1 dot keys. Okay, first let's print I. Oh no, range d1 dot keys, sorry, I didn't use length. Why to use mind again and again? Let's check here. Yeah, length of, no, not this one. Oh, pretty simple. Length of d1, forget it. have to use more mind in searching it. Okay, so basically these are the two fields. So this one will provide us, this one will provide us the two values, so we can straight away use it. For I in range, the length of, this is correct. From where did I copy it? Yeah, this one. The length will give 2. Now let's print I. Perfect. So we got two iterators, 0 and 1. Now we're going to use them in the loop where we get the values of these individual elements, field and manager. Now I can forgot where did I leave. Correct. Now this time don't print I. Now replace it here with I, so that it takes first the value 0 and then next time takes the value as 1. It doesn't go up to 2, stops at 1. Okay, correct. So we got field and manager, the two values out of this nested dictionary. Fine. Now we need to access the dictionary name. It's going to be quite complicated. So how do we access name? D1 dot keys, job, age and name. The third element of this list will be denoted by 2. You get name. Now just in your mind replace this with a perfect symbol, like let's replace it with symbol name. Symbol name is name. Okay, now let's get symbol name. Okay, pretty good. Now basically I'm replacing this thing, this one with the symbol name, so to make the things less complex. Otherwise you'll keep on seeing this value again and again and it gets puzzled up in the mind. So we'll just use symbol name for denoting the values of the key name. So this one is basically getting replaced by symbol name. Correct. Now let's go ahead. Now what we're supposed to do, let's replace this one also. New dictionary. Now what is new dictionary? New dictionary we have replaced this new dictionary with only these values, so that things are very less complicated for us. Now you better know how to iterate through this. New d dot keys will give you last and first. Now how do you access the values? Basically it's going to provide you a list, and wait, now if you provide the key inside here, not here actually, like this, new dictionary. Now we cannot provide new d as it is here, because new d, no sorry, it's okay, new d dot keys You cannot provide newd.keys same as it is here, because newd.keys itself is a list. If you do so, invalid syntax. Sorry, no. Again. Newd.keys. Newd. Now you cannot call this like this, because it will just tell you that it is a list and cannot hash it, because in dictionary things are kept with hashes. The values in their pairs are hashed and they are stored in the dictionary. So it's trying to hash the list, but list is not hashable. Actually, you can hash an element, string, or an integer value, or whatever, or a float number, that can be hashed, but a whole lot of list with multiple elements in it cannot be hashed. So basically you got to tell it that what to tell, got to say that dot keys is these last and first. So you need to provide him new one dot keys, give me the value of first element, the key is last, and next key is first. So basically first name is the key and last name is another key, and the values are I forgot what is name 1 and cast 1 something. So it gives you cast 1, because since the dictionary is sorted now itself by Python, so it can be somewhat up and down. And how do you access the first name? Simple, with this one. Now you can run it through a loop. For I in range, give it a length of what? New underscore d dot keys. Print. Now replace this with I. Getting in your head or not? So you get the first name and last name using an iterator. And now what else is remaining in this dictionary? So now almost everything sorry, now almost everything we have accessed in the list in this dictionary. Job name, that's pretty clear to how to you access this element of the dictionary. So just a moment, mic has got slipped. Okay, so proceeding ahead now. Just a moment please. Bloody mic. So now come on to the functions. Okay. Let's define the function. So defining a function starts with def. Was the first function is defined as 1. Now there is something like called scopes. The scope of function is, it starts from this place up to where it does end. So let's have an example, then you might recollect it. Okay, now then define another function inside of it. Then x. Now whenever you are defining a function inside a function, when Python runs this function, just initializes this inner function, it doesn't run it, just initializes it. Basically it makes the function and returns. So you need to return the value, return the function. Let return what function f2. Okay, now add function 1. Now the value x scope is starting from here and it ends over here at the end of function. And if you define another variable inside a function, this f2, its scope is limited from here till the end of this function. So x is accessible throughout this scope. Now you may run f2. No, sorry, act. So basically, let me do it again. Act is equal to, we call a function because we are not assigning any variables inside this function, so we need not pass any value. We are instantiating act with a function f1. Act is an instance of this function f1. Now what is act? They provide you act is a function f2 at so and so memory location. So basically now, since we have created an instance of this function, now act is passed on to this function inside, and it is just initialized. It doesn't run compile over here inside, and it will just return you the function so that later on you can use it. So now if you want to run this function exactly, you need to run it like this, and it will do the work for you. It will print the value of x. So remember I told you the scope of the variables inside a function, they are extended to this place. So print x is accessible over here also. Even if you define another function inside it, it will be accessible there also. So it prints x, which is taken from here. Okay. Another method of defining it is you run f2, sorry, here itself. Now the way we used to define it, you see the difference now. What's happening is where is that? In this scope we were just defining a function and returning the value. So function doesn't actually run here, it just gets initialized. But here what we are doing, when this function f1, we are creating an instance action, and as soon as action runs this function, since we are executing this function, when it is executed, it initializes this function and it finds f2 here. So f2, it gives a command to function that execute f2 now. So now here f2 is called, and f2 returns you the value of x. Basically not return, it prints the value. So now f2 is also called along with this. So what is action now? You see the difference between defining the function with like this and defining a function like this. So here f2 is called immediately, and you see the result. Now you can proceeding further. Let's define let's get the square values. Define, make a function and pass it a value n. Now you define another function inside. Here is this value whose not square actually, whose power you want to find out. So basically you want to find out what's the value of x to the power n. Okay, so return x to the power n so that we get this value in return. We are not printing actually here. Now again return act. Okay, the same way we did where it's got lost somewhere, I think. Yes, no, this is the same one here. Yeah, so we are returning the function, same here. Now I start from the first alphabet Q on the keyboard and we call it like this, make, and what do you want? You want the power 2. Now here this defines an outer function which is generating and returning a nested function. So this is always a nested function. So basically we call make by passing the value 2 to n, and it returns the function without running it here also, because we are not calling function here the way we were doing here. So the same way it returns it but doesn't call it at this moment. Now when we assign q to this value, we pass 2 here. Now n remembers the value 2, and now when you, now what is q? Sorry, q is function act, this one. Basically q is now this function. Now how would you call this function? You can call it using q. So the same way, like we are calling act by passing it a value, now you call it also, pass it a value 3. Now 3 square is 9. So this is a difference you should understand before calling functions, returning them, getting the values out of them. Now comes, let's go to the lambda functions on, basically lambda expressions. These are the as we told in the previous topic, lambdas are the ready-made feature in Python, so that you could use them without creating expressed functions, typical functions for small jobs. So for demo purpose, let's define a function called square. It takes a value n and returns you x to the power 2. Okay, pretty simple. Then square 3, it returns you the value 9. Now instead of using these 2 lines of code, you could finish it within 1 line of code only. Define square, and the syntax for defining lambdas is lambda, the same value x you provided here, use this expression of defining a function. Now you don't need to return the value here, it's already clear with Python that you are going to return something. So define now, and I'll get the value of 3 square. Okay, so lambda functions, lambda expressions are very handy in creating your custom expression, creating your custom functions. Now let's get into some more. Now you should practice this lambda expression, at least some pretty simple examples multiple times, so that it gets into your head how to use it. You should be comfortable with it, with the basic usage of lambda, because we are going to jump to advanced usage of lambda. No. Let me think about some examples on lambda and get back. Okay, so for getting into more advanced usage of lambda examples, let's go through one function map. Map is an inbuilt function in Python. So what it does is it accepts 2 arguments. First is the function, another is a sequence. Sequence can be a list, a simple list. Basically Map is used to create a list as output of this whole map. Okay, use map is a function inside first argument and a list or sequence or in range, whatever you like, and execute it. It will provide you a list. To show this example, let's go to where's the square function. This is square. Okay, so we'll provide it a function square and it provided a list. Is there any list? Okay, don't need to cross check. Use range up to 5. Basically range 5 will create a list. As we saw in the previous topic, it will create a list starting from 0 to 4. So we are providing a function and an iterable object, a list here, this map function. See what it does? It created so it created a list, gave us an output like we see here. It gives us the output and a list. So we got a list as an output. Now this square I've been using from here. Now if we use a lambda in place of it, what about lambda? You'll have to define a lambda here, x to the power 2. Let's enclose it in parentheses. And we call this weight. Okay, no need to define it. I was wondering whether there's any list called L1 or not, and if I use it, it's going to throw an error. Let's use this up to a list, which creates a list up to 4, and yes, it gives us the same output. You see, we don't need to define a function also. The function is inbuilt in this lambda. Basically, where's the square? This is square. Instead of defining a function, straight away use lambda from here, starting from here. This whole area is bypassed, and use x to the power 2 x. Basically lambda is defining a function by itself, and you define x and just return. You can assume there's a hidden return here, so x to the power 2, and we provide an iterable list to it, and it gives us an output, a square list. Now you can define nested lambdas also inside one lambda. How would do that? Let's go through first simple example. Define f1, you pass it a value a. Now again you define another function called f2, you pass it a value b. Again define a function called f3 and pass it a value c. Now you just return a plus b plus c. You can access b also, c also, and a also in this last function. Return a plus b plus c. Now you got to return this function f3. Now return this also f2. Okay. Now how do you access them? Pass a value 1 first. Now what is q? You see, q is function f2. Okay. Now if you want to use this function f2 and provide it or pass it a value, you got to call this function, call this value, and pass it a call this assignment and pass it a value. sorry, you have to assign it like this. Assign it a new variable called w, pass it a value q. Okay, now what is w? Now it says w is a function f3 at its memory location. So now w takes over f3 now. Now we call w with 3. Now what is e? Now e is returned with this value. Finally this function gets executed. It gets the summation of all those 3 values, basically a, b and c, and you get 6 at the end. Now you just count 1 2 3 4 5 6 7 8 9 10 11 and 12. It took us 12 lines of code to find out this value. So I'm not saying particularly about summation of three variables or 3 values, but it could be anything. You could use function to getting a hash of this, to getting a hash of b, then again use some other function to get some whatever means square root or multiple power of something here. Then you do some other maths over here to basically whatever your purpose is, then return these, and then finally you get this value. It's not particularly about summation of 3 numerical values, but it could be anything, any kind of operation you might want to use. So this whole operation can be replaced with one single lambda expression. It won't be a single lambda because you are defining 3 functions, f1, f2 and f3. So basically 3 lambdas you'll have to define. Okay, first make it simpler only. Let's first define a function here, then we will define lambda for these 2 functions. Okay, this is x. Sorry, it's my bloody keyboard and hands. Now you return. Now you define lambda here. Remember how lambda is defined. You can replace this square function starting from here. You can replace it with this lambda. Okay, so lambda x. Now what do you need to do over x? Because you're going to not x then. Why? Because x we already used. Now you need to pass it a value. It is just like this. A you already defined. Let's make it a. Let's make it b. So you already defined a here in function f1. Now you defined how to access the variable b, the second one. Now you need to do summation of a plus b plus c, correct? Now you can simply replace this third function with another lambda inside of it. So basically what we are doing, we are not doing any operation after defining a function with some variable. We are not doing straight away a plus b over here. We are waiting for it, defining another function here. So the same way you can define another lambda also over here. Define another lambda and we define c here. So basically a, b and c, we all covered them. And now you return simply a plus b plus c. Okay, that's it. Q is equal to f1 1, w is equal to q of 2, and e is equal to w of 3. What is e? 6. So from 12 lines we come down to 1 2 3 4 5 six lines. Now if you want to come down more, you can do that also. Yeah, one more thing. Okay, let's come on to later on. Okay. Lambda a, define again another function lambda b, again define inside lambda c, and return a plus b plus c, and let it be as q. No, not q. Let's take it as where. Again the same thing, q is equal to, no, I guess I'm making some mistake here. Let's see, what is q? Function lambda. Yeah, no problem. What is e? Now e is 6. Now in place of defining a function like this, first define a function, then define two lambdas, we have straight away defined it as this. You can do some mathematics on 3 variables at a time in just one line, one go, and you're done with it. Now let's reduce these assignments also, correct? So first what we are doing, we are defining an object to this. So let me think over it. Okay. Oh, great. So what we are doing here, basically first we are assigning q and passing value 1 to this whole function, this whole assignment. Same thing we done here. Now where 1 is assigned to q, now we are assigning w to function q and passing it a value 2. So basically you can replace w is equal to q2 with this, and then w3 with this. Okay, so just assume it like this, assume it's not here. So what it happens, q is equal to variable 1 where 1, then again you are providing value 2 to q only, see here. So now consider it's not there, just assume that there's only w. So what are you doing, replacing this and assigning q2. Just assume this is whole q only, keep a q here, and q of 2 you are passing to this lambda. Now this whole gets replaced, this whole replaces this one, and now you have to pass the value 3 to everything which you had defined till here, pass the values till here. So just assume this one as, what do you assume, till e, no sorry, till w you are passing the function, the values 1 and 2. Now just assume that this is w. Now you pass the value 3 to w and assign it to e. So basically all the 3 values are passed and we are assigning it to this one. Now you query for q, it holds the value 6. Okay. Okay. So what is this now? Now we have skipped all of it. We don't define, we don't assign this whole function q to where. We don't assign q to where of 1. We don't pass a value to q first using where. Then we don't assign this, or we don't assign this complicatedly, these values in this way. Basically we are defining a complete nested function here, and we are passing the values 1 to a, 2 to b, and 3 to c, and what we get, the resultant output. So just imagine 1 2 3 4 5 6 7 8 9 10 11 12 lines of code replaced by just a single line, nested lambdas. This is the beauty of Python and the inbuilt features. So isn't it great? These are recursive lambdas. Okay. What about the next example now? Let's make some example with lists. Okay, let's stop it here now. It's already 50 minutes. We'll cover them in next topic.